Okay, back to Chapter 8, percent composition problems. This is for exercise 8B. This is a great problem that you'll probably see a lot more in Chem 115 than you will in Chem 110. How many grams of nitrogen are in 252 grams of aluminum nitrate? Let's pretend that this quarter is 252 grams of aluminum nitrate. The question I have is, how many grams of this stuff are just from the nitrogen? Well, you need the percent of nitrogen in this compound, right? Well, how do we figure that out? Well, if you remember, whenever we did exercise 8A, we actually did a video that examined how to do this problem. I'll go back to that. There it is. Mass percentages of the elements in aluminum nitrate, and we figured it out for nitrogen. We took the total mass of the nitrogen divided by the total mass of the compound times 100%, got the percentage of nitrogen. So I'll repeat that information here on our problem. Find it. There it is. Okay, to find the percent nitrogen, we'd have to say 3 nitrogen atoms times 14.01 grams per mole divided by the total mass of aluminum nitrate, 213.01 grams per mole times 100%. We got 19.7% nitrogen. Okay? So this is part over whole times 100% is equal to the percentage. Okay? We're using that, and then we're going to use it again because this is that. We already know what that is. 252 grams of aluminum nitrate, well, that's the whole, right? And this is what we want to solve for. So how will we solve for part here? Well, we want to multiply both sides by something to get part all by itself. I think it's pretty clear that we're multiplying by W over 100% on both sides, because whole cancels out with whole and 100% cancels out with 100%, leaving you part on the left. And what's left? Percentage times W divided by 100%. Let's plug in what we know. 19.7% times 252 grams divided by 100%. Notice that percents cancel. We're left with units of grams. And 19.7 times 252 divided by 100 is 3 sig figs, 49.6 grams. Now, does that make sense? Sure it does. If it was 50% nitrogen, it'd be about 126 grams, something like that. It's 19%, so it's got to be something less than 126, about half as much as that, and that's about right. So that makes a lot of sense. Okay, but what if you didn't want to go through this process twice, this percent calculation twice? You can also do it by thinking of this as 1 mole and looking at the mole-to-mole ratio of the atoms to the molecule. Let me show you what I mean. 252 grams aluminum nitrate, convert to moles. 1 mole of the whole compound has a mass of 213.01 grams. Okay? Grams. Alright, so the unit and the label cancel out. We're at moles. Now we want to know how many moles of nitrogen are in 1 mole of aluminum nitrate. Well, there's 3 moles of nitrogen per every 1 mole of aluminum nitrate, right? Good. That cancels out. Now we're at 3 moles of nitrogen. We want to know the mass, and that's just 14.01 grams per every 1 mole of nitrogen. Guess what we get? Same exact value. And that's not really surprising, is it? Because 252 times the fractional amount of nitrogen is how we do that calculation. Well, there's 252, and 3 times 14.01 divided by the total, that's the fractional amount of the nitrogen in the molecule. So we've sort of done the same thing, but in one stretch of calculation. So 2 different ways to get the same answer. Practice those up.